This is a tutorial for Chapter 3, Section 8, titled Unions and Intersections of Sets. So let's take a look at the first type of problem that we'll see. It says find each union or intersection, and then it says let A equal this solution set, and B is all values of x such that x is positive odd integers less than 10. So positive odd integers, so it'd be like 1, 3, 5, 7, and 9. Those are less than 10 there. C is just these four numbers. D is all values of x such that x is a negative integer between -5 and -1. So a negative integer between those would be like -4, -3, and -2. So let's take a look at possible values here. And so A is the union. So union, this is the symbol for union. Union means all numbers that are involved in those sets. And so all values of A. So A includes 1, 2, 3, not 2, so let's take out the 2 there. So A includes 1, 3, 5, 7, and 9, where B includes those same numbers, 1, 3, 5, 7, and 9. So in this case, we would say since there's nothing that all the numbers duplicate, we're just going to use all those numbers. So 1, 3, 5, 7, and 9. Those are the different numbers that would be in this solution set. Even if, let's say, A had some extra numbers, like a 1 or a 2, or maybe like a 10 or an 8, those numbers would also be included in the union. So let's take a look at the next one. It says A intersect C. So let's take a look at what intersects. Let's draw a Venn diagram for this one. We've got, and then we'll write down what would be in the center, what they share in common. And so I see that C shares not only a 1, but it also shares a 7. See, 1 and 7 are in both these sets. So 1 and 7 would go inside here, where A also has 3, 5, and 9. C has numbers 2 and 4. So those are different values in A and C, and the ones that intersect are just in this location in here. So that would just be 1 and 7 would be the two solutions in this case. A and D, they intersect, and so we want to find the values that match, that would be together in both of them. So let's take a look at what A is. A is 1, 3, we've got 5, 7, and 9, where in D, that was for set A, D has just the negative integers of -4, -3, and -2. So there's nothing that intersects there. So this is the empty set, or we could say no solution in this case here. So let's take a look at one more problem here. Let's try one in which, let's go with a, how about A union, and let's go with A union C. So let's change that. It looks like a U there instead. So A union C. So you can see that an intersection is just the stuff that works for both of them, that they intersect, that they share in common. But when we're talking about unions, that means we're looking for not only what intersects, but all of what we have that for both sets. And so, for instance, A has 1 and 7 that both A and C both share. So we're going to rewrite this one here. We have 3, 5, and 9 are the other values of A. C has those two even numbers of 2 and 4. So when we're talking about a union, we're talking about the entire set here. So we're talking about all the values of A here, all the values of C, and everything that intersects, where when we're talking about just an intersection, we're just looking at what is in common between the two, like the 1 and the 7 were in common. So here we get to list all of these values. So 1, 2, 3, and we have the 4, we have 5, and we have a 7 and a 9. So when we're talking about a union, it's every number that is included in set A and set C. We just don't have to repeat the number if it's the same. For an intersection, it's just looking at what's in between, what they share in common. So in this next problem, they say we're supposed to draw a Venn diagram to represent the union intersection of these sets. So let's start off with some circles. And we want these circles to intersect so we can have some possible values that are the same. So we'll intersect some of these circles, and then we'll name them. So I'm going to make that last one a little bit bigger there. Alright, so this one we'll call V, this one W, and this one X. So when I'm looking at this, I'm looking for what is in common between all of them. And what's in common between all will go in this little section right in here, because this section encompasses circle V, circle W, and circle X. So let's find out what's in common. It looks like we have, each of these have a P in common. So I'm going to put a little dot next to what's in common here. So I'm going to put P inside there. And then I'm going to look at what else we have in common. Let's see here. This one has an I, but this one doesn't. T. Nope. How about B? Nope, I don't see that. I see B is with V, though, so now there's nothing else in common between all of them. So I'm going to start looking for some other parts here. V is common between just V and W. So V and W is this section right here. They intersect, so I'm going to put that in there. And I see no B down here, so I'm going to cross these off so I know I've taken care of those. And I'm going to look for something else that's in common. I look for T's, nothing there, no I's there. So now I can just put in for W, T and I in these two spots, and again I have the P right here. So I can put the T and I in just the W alone, so that's all that W has. Now I'm moving on to maybe the V here, M. So no other M, so V gets M all by itself, A. So no other A in X, so I can go ahead and put that one there. But I do see E is in common. You see how E is there and E is over here. So E is going to go in between the circle where it goes for circle X and circle V. So we'll put the E right there, and we'll cross that out since we've done that. And D. There's no other D in this, so we'll just put D with the in the circle V all by itself. Now we have the remaining ones. So G, R, and Z will go in circle X. That will not be part of W or V. And so that's our Venn diagram for that problem. Let's take a look at another one, and that one will be a couple word problems. And let's take a look at the first one here. It says a local parks department asked 300 people if they should build a new basketball court or a skateboard ramp. So this is the two parts that we have. So we have circle. One circle is going to represent the basketball court. So I'll just say basketball. And then the other circle is going to end up representing the skateboard. Ramps. And then it says they were not allowed to answer neither. So they cannot answer neither. They have to say whether they wanted the basketball or the skateboard or both. And so it said there were 233 people and they wanted a new basketball courts. Okay, so 233 people wanted new basketball courts, and 94 people said they wanted both new basketball courts and skateboard ramps. Okay, so 94 would go right inside there. So let's change the color, and we'll put 94 right here, and that represents both are occurring. And then what I need to do is find out how many wanted just the basketball courts. And so notice that 233 people said they wanted new basketball courts. And so 94 said they wanted both. So let's go ahead and subtract 233 minus 94, and when I do that subtraction I get 139. That's going to be the people who just wanted the basketball courts, because 233 people wanted basketball courts, but that includes 94 of those 233 wanted both basketball and the skateboard ramp. So subtracting gave me just the people who wanted the basketball court. So now I need to find out how many wanted just the skateboard. So let's go ahead and take the total, 300, and subtract the 233 who wanted both basketball and the skateboard. So subtraction of these two numbers gives me 67. That's how many wanted just the skateboard ramp. So that's the answer for that one. Let's take a look at the last one. It says each student at a particular school participates in at least one activity, sports or music. So those are our two categories. Let's go ahead and draw the circles. And I'm going to change that. I'm going to give myself a little bit more room to be able to fit that number in between there. So we've got sports and we've got music. And now it says 50 students participate in both sports and music. Okay, 50 are both, so I'm going to put 50 right in the center. That's the intersection. And so from there it says 200 students participate in sports. So what I'm going to end up doing is find out how many are in sports alone. So I'm going to take the total 200 students participate in sports. So I'm going to take the 200 and I'm going to take away the 50 people who participate in both sports and music. And that's going to give me 150. So I know 150 people just participate in sports alone, because again it said 200 students participate in sports, but then there's 50 that participate in both. So now I need to find out how many participate in just music alone. Well, it says that there's 250 students, and we have 200 of them participate in sports. And that included sports and music there. So we want to go ahead and do that subtraction. That's going to give us how many just participated in music. So 50 people have participated in only music. And that's our answer right there. So that's the Venn diagram for those. So those are the types of problems you're going to see on tonight's homework. Good luck.